Gases are everywhere. Gases can fill up container of any size or shape. Even this container, it also have gases. It doesn't matter how big the container is. The molecules spread out to fill the whole space equally. You have heard about the atmosphere. Gases also exist there. The atmosphere is an envelope of gases that surrounds the Earth. In solids, atoms and molecules are compact and close together. Liquids have atoms that are spread out a little more. The molecules in gases are really spread out, full of energy, constantly moving around in random ways. But these gases have laws, and we will tackle one gas law to you. By the way, I am Pigcaulan, and I hear you want to learn about the combined gas law. Students are also here to explain the varieties of our topic and for you to have more knowledge about the combined gas law. So let's get started to the introduction of our topic, shall we? Combined gas law consists of three primary laws: Charles' law, Boyle's law, and Gay-Lussac's law. So where our combined gas law belong? For you to understand, the combined gas law combine these three primary laws that I mentioned earlier. And what Paul-Émile Couplerion in 1834, a French physicist, who combined these three gas laws into one single law that was called combined gas law. But what does this law state? It states that the ratio of the product of pressure and volume and the absolute temperature of the gas is equal and constant. The gas law, which it's constant, its temperature, that is on Boyle's law, pressure, which on the Charles' law, and volume, which on the Gay-Lussac's law, is simply a combination of the other gas that works when everything except temperature, pressure, and volume are held constant. These three, which temperature, pressure, and volume are all present in the combined gas law. All of common equation for writing the combined gas law. The classic law relates Boyle's law and Charles' law to state P times V divided by T is equals to K, where P is equals to pressure, V is volume, T is the absolute temperature, and K is equals to constant. K is a true constant, is the number of moles of the gas doesn't change. Otherwise, it varies. One formula for the combined gas law relates before and after condition of a gas, which first pressure times first volume divided by first temperature is equals to second pressure times second volume divided by second temperature. Examples will be explained by Hanisa, Sanday, and Miriam to clarify to you this formula.
Hi, my name is Miriam Abdullah and I am here to give an example of combined gas law. Okay, let's start with our problem. A 5 liters air sample with negative 50 degrees Celsius has a pressure of 107 kilopascals. The temperature is raised to 100 degrees, but the volume also expands to 7 liters. And the question is, what is our new pressure? Okay, let's start with our formula. Our formula is P1V1 over T1 is equals to P2V2 over T2. After that, we substitute the pressure to be 107 kilopascals and the volume is 5 liters and our first temperature was 223 Kelvin. If you're wondering where did we get 223 Kelvin, it is the negative 50 degrees Celsius plus 273 Kelvin is equals to 223 Kelvin. And our new pressure is going to be our question mark because that's what we're solving for. And our new volume is 7 liters and we have new temperature of 373 Kelvin. If you're wondering considering also, it is the 100 degrees Celsius plus 273 Kelvin is equals to 373 Kelvin. Lastly, I need to break this down a little further by dividing each side by 0.0188, and these guys are cancelling out. I've isolated my pressure and 2.40 dividing by 0.0188, and the answer I get is 127.7, and my new pressure coming from this division is 127.7, and that's expressed to kilopascals, and that is our new pressure. Thank you.
Hi, good day. I'm Almansor Sanday, and I will show you how to solve the combined gas and law. This is a formula combined gas and law. Formula is a pressure 1 and a volume 1 divided by temperature 1 equals to pressure 2 and volume 2 divided by temperature 2. The given is volume 1 is at 8.33 low and the volume 2 is a 5.72 low and pressure 1 equals to 1.82 atmosphere, and also the temperature 1 is a 286 kinetic and the temperature 2 is a 355 kinetic. So let's find the pressure 2. The formula how to find pressure 2. The pressure 2 equals to pressure 1 times volume 1 times temperature 2 divided by temperature 1 times volume 2. Let's solve it. Pressure 2 equals to 1.82 atmosphere times 8.33 low times 355 kinetic divided by 286 kinetic times 5.72 low. First, multiply the pressure 1 times volume 1 times temperature 2 equal 5,382.013. And second, multiply the temperature 1 times volume 2 equal 1,635.92. Third, 5,382.013 divided by 1,635.92 equal the 3.22 atmosphere. So the P2 is 3.22 atmosphere. Thank you.
Hi, I'm Bai Hanisa Karim. So now I'm going to show you an example about combined gas law. And I'm going to explain it to you how to solve this problem and get the final answer. So our problem is, a gas has a volume of 800.0 ml at negative 23.0 degrees Celsius and 300.0 What will be the volume of the gas via 227.0 degrees Celsius and 600.0 of pressure? First is we need to set up all the problem values in solution matrix. The values of P1 is 300 torr, V1 800.0 ml, P1 250 Kelvin, and P2 600.0 torr. V2 is the missing. And last is P2 500 Kelvin. To convert the values of Celsius into Kelvin is you need to add the values of Celsius into Kelvin. So our values of Celsius is negative 23.0 degrees Celsius and 227.0 degrees Celsius, and our Kelvin is 273.50 Kelvin. So add negative 23.0 degrees Celsius and 273.50 Kelvin. So the answer is 250 Kelvin. And that is our values of T1. And next, add 227.0 degrees Celsius and 273.50 Kelvin. And the answer is 500 Kelvin, and that is our values of T2. The combined gas law is rearranged to isolate V2. The formula that we use is V2 is equal P1, V1 and T2 all over P2 and P1. Values are inserted into the proper place. You need to cancel out the same unit, which is the Torr and the Kelvin. Then you need to multiply the 300.0, 800.0, and 500.0 into each other. So the final answer is 120 million. Next is multiply the 250.0 into 600.0, and the answer is 150,000. Then after that, you need to divide the final answer, which is 120 million and 150,000, and the final answer is 800.0 ml. So our B2 is 800 ml.
Hi, good morning everyone. I am Bai Putri, Rohaina, Malang. If you're wondering why I'm wearing gloves, face shield, and I have this bottle, a bird egg, a piece of paper, and a lighter, it is because I am going to experiment and show to you how combined gas law applied in one experiment. So now let's start the experiment. First, light the piece of paper and put it on the bottle. And last, put this bird egg on top of the bottle. So now, let's do it. Oh, that's it.
Hello, good day. My name is Hashiem Urak, and I'm going to explain what happened on Malang's experiment. If you notice, Malang put the boiled egg on the top of the bottle. The egg is not fit to the opening of the bottle because the egg is bigger than to the opening of the bottle. Since the pressure inside and outside of the bottle is the same, the only force that pushes the boiled egg into the bottle is gravity. But the gravity is not too strong enough. The bottle is full of air molecules. When Malang dropped the flaming piece of paper and she put the boiled egg on the top of the bottle and the flaming piece of paper heats up, the air inside of the bottle in a gas air heated. The molecules move faster and it spread apart. It is because the air is trapped inside the bottle. The volume of the space it won't take up is limited. Once the air has filled the volume of the volume of the bottle and cannot spread any further apart, the air molecules start to press the wall of the bottle. And since the wall doesn't move, the air press inside the bottle doesn't increase rapidly.
In this experiment, we can conclude that temperature and pressure are directly proportional. Also, the temperature and pressure are universally proportional to volume. This proved by the combined gas law. This is the combination of Boyle's law, Charles's law, and Gay-Lussac's law.